simple box program. It's pretty easy to do when we have our robot that is facing in the same direction of its own origin point, facing the work that it's actually going to be performing on, and it's on a nice flat table that the robot sits on. And that just doesn't happen in industry. So right now it's pretty easy for us to move in world mode in that nice, neat XYZ method to be able to develop a program and work off of this origin. But in actuality, what we're going to see more often than not is that these robots are going to be placed in a lot of different situations, and they're going to be in a lot of different angles, sometimes almost 270 degrees from one side to the other. So an example of this, and a really useful tool that we can use to help deal with that type of environment, I'm going to put the robot into joint mode, and I'm going to jog it to another marker on the table, another box for another project kit. And this one, as you can tell, is not directly in front of the robot origin. And what you can see is that I don't have as much flexibility as I do in the first box. If I go back to world, boost up my speed, I don't get nice, neat lines coming from where the robot work should be taking place. If I want to get to the top of this marker right now, I have to stair step over to get there. And that's really painstakingly frustrating, especially when we're in world mode and we're supposed to be able to move in nice, neat, clean, straight lines, and all of our joints are working together. So what we need to do is we needed to define the work of where our robot is going to be facing, where the orientation is, where the origin is. We're going to set up what we call as a user frame. And a user frame can literally be set up anywhere in space. It can be off the ground, it can be up in the air in the robot. It's wherever the work is being taken place. We're going to make it real simple, and we're going to start with a two-dimensional user frame. And what I'm going to do is, I'm going to get a little bit closer, but I'm going to basically define a user frame from this origin point. And I'm going to make it, I'm going to go over one more little bit there. And you can see how it's a little bit of a struggle to even do that, because you have to stair step over. What we're going to do now is define the user frame. Am I on it? There we go. We're going to define the user frame a couple of different ways. And this is not something that we do in the program menu. This is something that we do in a setup and frames menu. So you're going to go to menu on your teach pendants, scroll down to setup, and then scroll over, scroll down to frames, and then I'm going to hit enter. Now, you might see a couple of different frame menu depending on where your robot's at. If you take a look at other, you'll see we have tool frames, jog frames, user frames, cell frames, and cell floor. We're going to be focusing primarily in this progression on tool frames and user frames, but specifically the user frame right now. So whenever we change our coordinates, the way the robot moves, you can see we go from tool to user to joint, to jog frame to world. Those are actually different frames. And the world frame is kind of the default frame. It's actually the robot origin. So the robot origin is actually at the base of the robot facing out. So that's why when we just put it into world mode, it goes to default origin. If you hold down the shift coordinate button, you'll see we actually have different options or a little bit more definition for each tool, jog frame, and user frame. So like I said before, the default world frame is user frame 0, and that's just at the origin or base of the robot. And we currently have tool frame 1 in place for our end of arm tooling. So I'm going to step back, and if you look at our screen, you'll see we actually do have a user frame that has already been defined, and I believe that is for another project kit. So we're going to leave that user frame alone, and we're going to go down to the user frame 2, and this is one that we are going to define. So when we do that, I'm going to hit Detail, and there are a few different methods that we can use to define the user frame. The easiest one is the 3-point method. The 3-point method requires you to record an origin point where the work is being placed, and think of it as the corner of a box or a corner of a square space where you're going to do the work. And then you record another point in the X direction and the Y direction. Now, one thing I do want to point out is I'm going to go back and I'll show you. Anytime I move into a menu, they actually give you a reminder. The active user frame right now is user frame 0. And you can see that user frame 0 is our world mode. And we're going to leave it there for now because that's how we're going to move the robot. But when we go back into the user frame menu, you can click Method, and there's a 3-point method, 4-point method, or direct entry. We're going to keep it at 3-point method. And when we do this, we're actually going to scroll down to the orientation origin point, which is right where my laser is pointing to right now. So with that, we can hold down Shift and say Record. And it says that the orientation origin point has been, a new position has been calculated. If I go down to the X direction point, I'm going to now move, and this is where you still kind of have to zigzag. This is where you kind of have to zigzag, moving out in the X direction from the origin of the robot. To basically as far as the where the work is going to be taking place on that robot. When we do that, we're going to hold down Shift and hit Record. And then when we go down to the Y direction, I'm basically going to return back to my origin point. Whoops. Back to the origin point, and now we're going to move in the Y direction of where the work is going to be done. And we're going to record that Y direction point. All right, so now we've recorded 3 points for that user frame. And this is where we'll be able to check if we did this correctly. We can actually go up to our orientation origin point, hold down Shift, deadman switch, and go to Move To. And you'll see the robot moves to directly to that point. Go in the X direction. We can move, or the Y direction, move there. You go to the X direction, and it'll move straight there. So we've recorded basically our 3 points for that specific user frame. Now, if we were jogging the robot, we still have to zigzag back and forth to move around. But that is because we are currently in user frame 0, or the world frame. But if I go back and I hold down Shift, coordinate, scroll down to user, press 2, and you'll see it disappears right away. You can always confirm if you hit it correctly by just doing Shift coordinate again. And if you don't want to change it, just do previous. And what we also need to do is change our coordinate into that user frame. So now we are actively in our user frame. And if I go back to a different menu, you're going to see the active user frame is user frame 2. Watch what happens now if we have done this correctly, and we can now jog our robot in the new user frame. Nice, neat, straight lines with X, Y, and Z. So now all the work that is taking place in this defined user frame, it's going to be much easier for us to create a program, make any adjustments, and do more complex robot operations.